Assalamualaikum and good morning. My name is Muhammad Hafiz Sharafuddin bin Muhammad Zahir. I will present about refrigeration system. This is my content in my slide. Thermofluid is a multidisciplinary field of science and engineering that combines the study of thermodynamics, fluid mechanics, and heat transfer. Refrigeration systems are prime example of thermofluid system as they rely heavily on the principles of thermodynamics, fluid mechanics, heat transfer to function. Refrigeration system demonstrate the integration of thermofluid principles in practical application. So this is the type of the system. A refrigeration system is generally classified as a closed system that consists of a fixed amount of mass. Energy is exchanged through heat transfer and work input. Then the refrigerant mass remains constant within the system, flowing through components like the compressor. The system boundary encloses all components of the refrigeration cycle, preventing the refrigerant from leaving the system. This is the cycles of the system. The refrigeration system operates on the vapor compression refrigeration cycle. The refrigerant absorbs heat from the cool space, evaporating at low pressure and temperature. The vapor refrigerant is compressed to high pressure and temperature. After that, the high pressure refrigerant releases the heat to the surroundings. And the last one, the refrigerant passes through an expansion valve, reducing its pressure and temperature. So this is the refrigeration principles example. This is the compressible flow of the refrigeration system. In a refrigeration system, the refrigerant is often treated as a compressible fluid, particularly in the compressor. Match number analysis, which is ensures flow speeds remain within acceptable limits to avoid shocks. After that, in density variations, changes in pressure significantly affect the refrigerant density. And then the continuity equation is P1 A1 V1 equal to P2 A2 V2. So this is the other properties of refrigeration system. We get the thermodynamic properties and fluid mechanic properties. So this is the example of workability in refrigeration system, which is the complex system is non-ideal behaviors. For the refrigeration cycles, the non-ideal behaviors is pressure drops. Then the solution we can use pressure and flow control. After that, for fluid mechanics, non-ideal behaviors like turbulence. For turbulence, like instabilities in flow distribution. So the solution we can use advanced control system. So this is the calculation for thermodynamic cycle. The example for compressor, we can calculate the work input, which is mass flow rate times specific enthalpies. Then for the performance matrix, we can calculate the coefficient of performance. So for the fluid mechanics calculation analysis, the example give is refrigerant flow. We can calculate the pressure drops in piping equal to friction factor times length of pipe divided by diameter of pipe times with density of refrigerant and velocity divided by 2. So for the heat transfer rate equal to overall heat transfer coefficient times with heat transfer area and times with logarithmic mean temperature difference. So this is other calculation analysis. We have computational fluid dynamics analysis. The example give is governing equation. So the conclusion that I get from this assignment, a refrigeration system is an integral component of thermofluid systems that leverage thermodynamics, fluid mechanics, and heat transfer.